All right, now, I said I think that's a more common sense way of getting to this result, but the proof that you'd be expected to produce is actually backwards. So let me give that to you instead. So just to make sure we're all on the same page, okay, this result here, okay, that's what, in an exam, they could totally say to you, prove this, part one. And then part two, hence, blah, 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 and actually solve the question, okay? So how do you go about it? Because I'm going backwards, okay, you start here, okay? Now this is why I don't like this proof, even though it's sort of the one that all the textbooks use, and it'll be the one that you actually probably will memorize, okay? I don't like it because, sort of like, why? Why this? What does this have to do with anything, okay? Whereas this, I at least get, it starts from something that I already know, whereas this seems to come out of left field, okay? But as you can see, all of my working is actually going to be more or less identical, but in reverse. Alright, now, if this is what I'm differentiating, for some unknown reason, how do I differentiate this? Now, this is chain rule, okay? We sort of anticipated that because all of this is chain rule, right? So therefore to make this work would also be chain rule. Right? Now let me write something in to sort of clarify this, right? I'm differentiating with respect to x. What I'm differentiating is a function of x. Okay? I'm trying to make the chain rule a bit more obvious here. Okay? So if you are differentiating, you've got chain rule here, right? We're used to calling that like a u of x, your inside function, okay? But you guys can deal with different letters, right? How does chain rule work? You differentiate the inside, and then you differentiate the outside, right? So differentiate the inside. The inside function is v, okay? So I guess the derivative of v would be, I mean, you could call it v dash, if you like, or you could call it dv on dx. Okay, that's your inside function, or rather the derivative of the inside function. Okay. Then, when you want to do the rest of it, you have to do the outside function, which is half of something squared. Half of something squared, so that's just a regular old polynomial. So you do what you do to all polynomials. You bring the power out the front, and then you reduce the power by 1. Right? So that lands you back at v. That's the outside. So far, so good? Alright, now, what am I going to do with this? Well, I know what v is. By definition, v is dx on dt. Okay? And again, you can see an instance of chain rule happening. So I'm going to cancel my dx's, which leaves me with dv on dt, which again, by definition, is x double dot, or acceleration. Okay? So you can see I landed at the same spot. I think probably the reason why textbooks like this is because there's less of a, let's put in dx's. That's what they think is harder. I think this conceptual leap makes more sense, but this is what they prefer. So it's equivalent, alright? I think this is what they'd be looking for you to actually create. So you need to remember this half v squared business, okay? And then from there, the rest of it just falls out, alright? Any questions so far? Okay.